Hello all, welcome to another LeetCode problem. Today we are going to solve the problem number 752, open the lock. So this is quite interesting problem where we have given a circular wheel which is basically 4 digits, and then wheel can rotate and then can possibly generate 1 to 9 numbers. But the challenge here is that the wheel can rotate either at the front side or the back side. It can rotate basically freely. So if you rotate at the front, let's say 0 is there. If you rotate front side, so it will generate 1. If you rotate at the back side, it will generate 9. And then using these combination, you need to find whether if you are able to reach the target or not. But the condition given is there are possibly a dead node. If you reach one of the dead node, so you don't need to proceed further. That's going to be like an end of the tree. So what is the sequence they're looking at? Start from 0 to incremental, let's say 0 is changed to 1 and then followed by these diseases. So what is the minimum number of steps required to reach the target? Whether if you're not able to reach the target, you just return -1, which is the, let's say, third case here, right? So if we think about this problem, right, so every possible combination that we can think of. So let's say start with 0 0 0. So your starting point is 0 0 0 0. So this 0 can change to 1 to 9, and then same way for this 0 as well, 1 to 9. Same way for this 1 to 9 and this 1 to 9. Correct. So let's say if I just rotate only first wheel, so what I'm gonna get is 1 0, and then rest of the system remains same. If I just rotate second wheel, so I'm going to get 1 0 0 0. Likewise for this one, 1 0, sorry, 0 0 1 0, and then for this one 0 0 0 1. So if I just rotate this towards the front side, but if I rotate in the reverse directions, what I'm going to get is 0 0 9 0 0 and 0 9, again 0 0 0 0 9 0 0 0 0 9, right? So after one rotation, there is a possibility that I'll get all these 1 2 3 4 8 possible combination, right? After rotating one of these particular wheel. So but if I go to the next level, so we need to see that there is a possibility that if I, let's say this one, right, if you rotate back, it is possible that I may reach to same node. So if that happens, so I'll ignore this node. I'll not consider this particular rotation. Or there is also possibility that I may reach to one of the dead node after doing multiple rotation. So let's say after doing multiple rotation, I reach dead node. Dead node is specified in your list. So if I reach the dead node, so I'll not proceed further. Don't proceed. Don't proceed further. Okay. So basically every pair which is given here will generate 8 possible combination, right? And then again this pair will again generate 8 possible combination. And if one of them is dead node, or if I'm reaching back to any of the previous node, so I'm not going to consider that there is also there is a possibility that that's going to happen, right? So how do we solve this problem? So first is, when a given node, right, when a given particular pattern, if we have, let's say, what is the next pattern you need to determine. So for that, what I'm going to do is I'm going to create a dictionary where I store the next pattern and the previous pattern, and then previous. Let's say if input is 0, so what is the next possible value I'll get? If input is 1, then what is the next possible value? Likewise, if input is 8, then 9. And let's say if I reach 9 input, so as a dictionary I'll store it 0. Second, for previous as well, let's say input is 0, so previous is going to be 9, because I'm rotating now wheel in the reverse direction. Likewise, if input is 9, next pattern is previous pattern will be 0. So I'm going to store these two pattern to generate this 8 combination. So first is this is like a next pattern, and this is like a previous pattern when you rotate the wheel in the reverse direction, right? So this, and this one is for forward direction, correct? Now I start, so also I'm going to maintain a dictionary that is like a starting point. So when I'm at the 0 0 0 position, so my steps taken will be 0, and this is my starting point. But as soon as let's say I reach to another node, let's say 1 0 0 0, so steps taken will be, so previous steps taken was 0 plus 1. So I'm going to reach 0 plus 1, that is 1. So in the new dictionary, I'm going to have 1000 and the value will be 1. Right. Likewise, I keep incrementing, let's say to 100, any particular node, and then number of step will be previous step plus 1, previous step plus 1. So next step, that is because every step, next step will be plus 1. So there's a two case here. So in case if I'm going to back to any previous state after changing one of the nodes, I'll ignore that one. And if in case if I reach any of the dead nodes, so I'm going to ignore that particular node. So I'm not consider it for further traversal. So let's look at the code here. So as I explained, so I'm going to maintain a dictionary first. So this dictionary is going to give me the entire possibility. So what is the previous, what is the next, and then previous combination possible. So let's say if you pass 0, so what is the next combination? If you pass 1, what is the next possible value? And same way if you're rotating the wheel in a reverse direction, so if you pass 1, so if you rotate reverse, you'll get back to 0. If you the current position is 2, and then if you rotate reverse, you get back to 1, right? So before I talk about children, let's talk about the helper function I have written. So in the helper function, I have a step dictionary which starting point is 0. So at 0 0, you are at 0 step. You have not taken any step further. And then I'll use the DQ here, which is basically going to store your starting point, which is your start node. This is 0 0 0. Now if any of the dead nodes present, so I'll store it as set, so which is basically input to your application program. Now I did a pop on the queue, which is 0 0, and see if this is equal to target. I'm just going to return the number of steps. So in the step it is 0, so initially is 0, so I'll just return the corresponding value here. If not, so now I'm going to do it for this traversal. So I'm going to find for this 0 0 what are the possible child. So let's say from here, so for this 0 0 possible childs are 1 2 3 4, these are all 8 nodes, right? So these all 8 nodes will be generated from this particular function, and once I get all the 8 nodes here, I'll make check if one of the child is not into dead nodes and also not present in the step, because if it's already in step, then I'll just ignore that. I'll not consider it again. And then finally I'll append the child, and then I'll increase the step count by 1. So previous step count, which I explained, plus 1. So let's say for 1 0 0 0, so previous step count will be 0 plus 1, right? And then further, in case if I don't find any pattern target, so I'll just return -1 as a result, right? Now to calculate the children's here, so I know that there is a 4 digit, so 0 0 0 0. So I'll take each digit first, and then I try to generate what is the next pattern, and then I'll append the remaining values. So this is basically a string, so that is a new pattern. So for example, so if you're passing 0 0 0 0, so next pattern will be 1 0 0 0. So that is going to be your new pattern. And in case of previous pattern, for the same 0 0 0, I'm going to generate N900. So I'll look into the dictionary for first character 0, what is the previous possibility value, so which is 9, and then again I increment, and for each digit I'm going to do the same, and that result will be appended to this result set, and this result set I'm returning here, which will basically do further trails. Hope you understand this problem. So that's the logic here. uh, you can just run it. Works, and then you can just go ahead and submit. Hope you like the video. Thank you for watching.